Okay, as Dave said, I'm Merv Chapman. First involved with district heating back in 1994. I'm originally a civil engineer. Was involved in heavy civils, but for some reason I got involved with the DH world, and ever since then I've been involved with ABB, Alstom Power, Vital Energy, and for the last 15 years with CPC Civils. CPC have been involved in the DH sector for about 30 years. We've worked all over the country and with the majority of all the energy companies, just about every town and city down the country. As well as DH, we're also involved with flood alleviation and water companies, Yorkshire Water and Severn Trent. So, there we go, flood works, works for Canal River Trust. It's our experience working on water and the DH networks, I think, that brought us to the attention of Dave a few years ago. Kind of put us in a unique position in the marketplace. There's DH installers, and then there's companies that work on water, but there wasn't a company that did both. So when Dave was starting to look at river source heat pumps, we were, well, I did a bit of a Google search, and up we popped on both searches when he looked for water companies and for DH companies. So where's Mike Mogridge? There you go. Is how to dig a float. Yeah, so we're an ideal place for doing the extraction points, and as the previous slide, for putting the pipes in the ground as well. So probably enough about us as a company. What can I tell you about the best thing to do when installing a DH network? It's fairly simple. Planning, planning and planning. It's a slide that was seen earlier. This is the Leeds scheme that's being looked at the minute. So often we find that the schemes are thought about, studies done on them, designs are done, and a heat-on date is selected. And then the contractor's brought on board. And generally the contractor's brought on board the project fairly late on, to say the least. And we rock up and we start saying to the designers, well, why didn't you do this and why didn't you do that? And by that point, generally it's too late. The scheme's gone in for planning. So yeah, my sort of message is that if you don't plan, things will go wrong, and they'll generally cost the project money, time and reputation. There's no reason a DH underground network can't be planned as if you was building a new boiler plant or heat station, but it generally isn't. Generally, you'll find that there'll be 2 points on a drawing, a heat load and a heat source, and there's not much consideration of how those points on the map are going to be joined up. I think you need to realise that clients need to have this upfront commitment to early contractor involvement, scheme development and proper design. This will see a heat network with a much lower installation cost and a quicker development time. I think I've said this already, but our experience to date is on many occasions clients will be involved with DH network only once. However, the people most experienced with the heat network installations don't come onto the scene until the whole of the project design is complete. And by this point, the chance to influence the design, the route and the scope is very limited. There should be the opportunity to make some large improvements in quality, and with the right mindset at the beginning of the design process, maybe a lot of value engineering could be carried out before a contractor is appointed. So how can this be achieved? going on to some things that Michael was saying earlier, carry out extensive research on the ground that's to be excavated to determine what the ground is made of and what's in it. A very large cost to a project can be if the DH network needs to be run through an area of contaminated ground with asbestos on an old brownfield site, for example. Hugely influence the cost. Water table is important. We don't want to be digging and putting pipes in underwater. Even though we can do it, we don't want to be doing it. It's expensive. Rock, having to dig through rock is expensive. And buried services. So there are ways and techniques that can be applied, and just upfront investigation that will allow the designers to be able to route maybe pipe work away from these problem areas. 3D mapping has got a lot better of late. It's just a screen grab from the internet, but this is a typical 3D mapping exercise now. It can show you position and depth of existing services, and armed with this information, designers can now start routing pipework to miss some of the more congested areas, major road crossings and the likes. Now, this isn't always, I mean, it should be straightforward, but it's not always thought about. Like I say, quite often it's just a line and not a lot of considerations given to this. Hugely influences the cost of a DH network, and you know, obviously, we're trying to reduce costs all the time. Sorry. Some of the other things that can be done: employ experienced designers with experience of district heating network, previous projects, to actually look at the district heating network. If an obstruction can't be avoided and you have to route your pipe work through that obstructed area, they'd be able to design the system to take into account the thermal expansion rather than the sort of suck it and see attitude that we quite often see. As the previous speaker said, can we drop system temperatures to allow the installation of plastic pipe systems, on the whole, cheaper and quicker to install? Most of the stuff that we do is steel, but I know it's much cheaper putting the plastic in the ground, and if we can get that plastic in soft areas, as alluded to earlier, a lot cheaper. Carry out consultation with stakeholders along the route. It's an important thing. Quite often we turn up on a job and the local businesses don't know we're coming, and straight away they're up in arms. The first thing they want to do is know how are they going to get to work, how's it going to affect their customers. If consultation is done early, you can get these guys on board. They expect a little bit of disruption, but if we can talk to, and get this consultation going, there might even be an opportunity for heat sales to these people. You know. Look at multi-service installations. Not often you get an opportunity to, but yeah, comms, power, DH, all in the same trench, reduces the costs massively. It's not often it happens, but occasionally it does, and when it does, let's say it works. So, with all the knowledge of the risks and potential problems that exist on a site, a client can set about designing a pipeline that will be slightly longer maybe than first planned, but should have a lower construction cost. And the other benefits will be better quality of installation and longer lifespan and better relationships with stakeholders. Steve mentioned earlier about 75% of the failures on the DH network come from on-site wells. If the numbers of wells can be reduced, because we know about existing obstructions, we can reduce the number of potential failures. So that was about the installation and designing the actual installation. At the same time, you need to be thinking about, when you're designing these things, about a quality plan, a test and inspection plan, a plan for commissioning that system, and performance testing, and then ongoing maintenance. Again, not always thought about at the early onset.